Understanding the optimal merge pattern problem.
Optimal merge patterns solve the challenge of combining multiple sorted files or data blocks with the lowest total cost. Each file has a size, and merging two files costs as much as their combined size. The goal is to find a way to sequence merges so that the overall sum of these costs is minimized, making data processing much more efficient.
Why merging efficiently matters.
Efficient merging is crucial when managing large databases or external storage, where inefficient merges could significantly slow down performance. By minimizing computation costs, systems can handle massive datasets, such as in file compression or search indexing, much faster. Optimal merge patterns help save time, computational resources, and even energy.
Greedy approach, the core strategy.
The most effective way to achieve an optimal merge is by using a greedy algorithm. This approach always merges the two smallest files available at each step. By doing so, it consistently keeps future merging costs as low as possible, leading to a minimized overall cost. This simple yet powerful method guarantees the best solution for the problem.
Implementing the optimal merge pattern.
To apply the greedy technique, start with all file sizes in a list. Use a priority queue or min heap to always pick the two smallest files. Merge them and add their combined size back to the queue. Repeat until all files are merged into one. Each merge's cost is added up to give the total minimum merging cost.
Real-world applications and benefits.
Optimal merge patterns are found in file compression systems, database management, and big data processing. By minimizing merge operations, these approaches directly contribute to faster algorithms in sorting, data storage, and retrieval, making them essential for scalable and efficient software systems.